So let's start with carbohydrates. Carbohydrates are made up of simple sugars. And we call these simple sugars monosaccharides. So a monosaccharide is a simple sugar, and most all simple sugars contain between 5 and 6 carbons. Some have a few more, a few less, but typically the ones we'll look at contain 5 or 6 carbons. And one of the most ubiquitous is going to be glucose. And glucose, also we have some other ones like fructose. Glucose can combine with fructose to form a dimer or a disaccharide, and this is what we find in table sugar. So let's look at the structure of glucose, and then we can talk a little bit about its properties. So here's glucose, and you immediately notice that it has a lot of oxygen in it. Glucose has 6 carbons, 6 oxygens, and 12 hydrogens. And in fact, if you look at carbohydrates in general, they have a carbon to hydrogen to oxygen ratio of 1 to 2 to 1. So our glucose has 6 carbons, 12 hydrogens, and 6 oxygens. So it adheres to this ratio. And we can see that these oxygens are covalently bonded to carbon and to hydrogen. So what does that mean? That means that this is a polar molecule. It has polar covalent bonds, and polar covalent bonds like water. So sugar can interact with water. So if you've ever dissolved table sugar in water, you know that it dissolves completely. So what we will see is that this sugar molecule will be completely surrounded by water. So the positive end of water will be oriented toward the negative end of this polar molecule, so this oxygen. So this creates what we call a hydration sphere. And so just like sodium and chloride ion are dissolved in water, so will individual molecules of sugar be dissolved in water, because water will form a hydration sphere around each individual molecule of sugar, so that now the sugar is floating around in the water. Now let's talk about solutions. A solution is a uniform mixture of 2 or more substances. The liquid part of the solution, and most of the solutions we will be talking about are liquid. There are some gas solutions, but we'll not be discussing them in here. Liquid solutions contain a solvent, which is the thing that is doing the dissolving. In this case, it would be water. Almost all the solutions that we'll be dealing with in biology and in this class will be water-based, so the solvent will be water. And the thing that is dissolved is the solute. So in this case, our solute is the sugar. And so when you have a solvent dissolving a solute, you get a solution. So this is one of the properties of sugar. Because it has all of these oxygens in it, it is polar and therefore can interact with water. Now let's take this molecule and let's abbreviate it. So we can write shorthand for sugar, so I'll write a shorthand for glucose, where we simply denote a ring that has an oxygen over here in one of these corners. So this is understood for glucose. And so we can link one glucose to another simple sugar. It could be fructose, it could be another glucose, and we'll denote a linkage between the 2 glucose molecules like this, with an oxygen in here. And now we have a disaccharide, because we have now linked 2 simple sugars or monosaccharides together to create a disaccharide. We could keep linking glucose molecules together. We could form glycogen in such a way, and we would have a polysaccharide. So basically, we can consider a sugar, a chain of sugars, as a polymer. So a polymer is a chain of things that are stuck together, things that have similar nature. So if we stick a monosaccharide together with another monosaccharide, we have formed a disaccharide. And if we keep on sticking monosaccharides on here, we will get a chain of monosaccharides that is a polysaccharide. And more generically speaking, the polysaccharide is a type of polymer, where mer just stands for a single unit of something. And so sugars can build starches. We can build starch out of simple sugars just by linking them together. And glycogen, which is sometimes referred to as animal starch, that is found in abundance in human skeletal muscle and liver, glycogen is a method of storing energy. So carbohydrates are very good at being broken down for energy.